So for this next part, you can see our standard Logger Pro apparatus, and what I want to focus in on for you is the circuit. It's a series circuit of a battery, that's the positive end right there, going around to a switch, and then in this position through the green wire there's a resistor. It's actually two resistors in parallel. They're 3 mega ohm resistors in parallel. And so resistors in parallel add like reciprocals. So that's 1/3 plus 1/3. Both of those are mega ohms. So that's 2/3. And then the equivalent resistance right there is 3/2 mega ohms. That's 1.5 mega ohms. Then over here you have a 1 microfarad capacitor. And then you're coming right back to the battery. Now, with the switch here in the other position, you have another series loop, okay, and all that does is it allows the capacitor to discharge through the 1.5 mega ohm resistor. And the capacitor, if I didn't say it, you maybe even read it on the side here, is a 1 microfarad capacitor. So what I'm going to do is I'm going to start with the switch in that position right there. We'll back out a little bit so that you can see the computer when I flip the switch. And I can see the computer's not doing a great job of being visible. So I'll make another video of that, and I'm also going to send you the results. And let's see, now what I'm going to do is I'm going to take the voltage sensor, it's a voltmeter, and I'm going to put it across the 1 microfarad capacitor. Red side on one, black side on the other. Okay? And then I'm going to take the switch after starting Logger Pro from the position it is, which is allowing the capacitor to discharge, over to the other side so it can charge. And so let's start Logger Pro. And you can see as the capacitor charges, the voltage across it increases, and it's doing what I call an exponential buildup. Once it's down, I'll let it now discharge, and you can see it exponentially decays back down to 0. Now I'm going to switch the location of the voltmeter. Instead of being across the capacitor, I'm going to put it across the resistor. And again, we'll hit start, collect on Logger Pro, and you'll see the voltage jumps up and decays away exponentially as the capacitor charges. And then if I go to the other way, ooh, it looks like the voltage has switched polarity, the current has switched directions, and is now going in the opposite sense around that loop. All right, and now to give you a better view of the Logger Pro screen as I do this experiment, we're going to start again, and I'll hit collect, and right now the capacitor is fully discharged, and I'll hit start. I'll flick the switch, let the capacitor charge, and once the capacitor is charged, I'll flip the switch back the other way. It looks like I have my fingers on the switch a little bit. That's what that little glitch is right as I switch position, and we're done. Now I want to show you what you should be able to do out of this, and I need each and every person to do this. I'll send you a file. I want you to do a fit over that range right there, and I think the fit that you want to pick for this range is the exponential buildup, which looks like it's right there. A times 1 minus the exponential of minus ct plus b. Let's try fit, and looks pretty good. And I think the coefficient C should be related to the time constant, the product of the resistance and the capacitance. Once this little glitch right here is done, let's do the same thing on the discharge portion of this cycle. And let's do a curve fit, only this time it's an exponential decay. And so let's find the exponential decay function. Ooh, nope, not there. There it is. Exponential decay. Try fit. Looks pretty good. Hit OK. Bring that over. And again, the two numbers for the C are reasonably close. And again, I'm going to save this for you here in a second. Now, I want to switch over to looking at the potential across the resistor, which would be proportional to the current going through the resistor. I'd love to use an ammeter. They just aren't sensitive enough to detect the very low volt, the very low currents we have here. They're of the order of micro amps, and not enough for the current sensors to work. So this time we'll hit start and take the switch over and look as voltage goes down because current is going down as the capacitor charges up. And now I'll flick the switch to the other side, and oh, what you notice is the polarity changed again because the direction of the current in the loop changed as the circuit discharged. Now let's redo these fits. Okay, just move our little markers that tell us what range of the data we're fitting. And you can see I've got about pretty similar, about 0.69. I saw 0.7 last time, and that number right there, that value C, is related to the time constant, again, the product of the resistance and the capacitance. Capacitance here, 1 microfarad. The resistance, 1.5 mega ohms. You should be able to figure out what the time constant is and then compare it to this fit parameter C that Longer Pro is doing for us.